So today we are going to learn how to sort an array of all zeros, ones, and twos. Here we have given an array that contains zeros, ones, and twos. What we need to do here is I should need to sort this in like this: 0, 0, 0, 1, 1, 1, 2, 2, 2, 2. So I need to sort the array like this. Sort an array like this, right? So this is what they're saying to do: sort an array of all zeros and ones, twos and twos, right? This is also say similar question for sorting colors as well. So okay, let us start from the brute force solution. Let us start from the brute force solution. Let's say brute force. What is my brute force? Well, what will we do? We just sort this array. If we use merge sort, if we use a merge sort, then it will be then the time complexity will be n logarithmic of n, and the space complexity will be big O of n, right? Big O of n, because we're using a temporary array, because we use a temporary array if we do merge sort, right? So okay, this is the brute force solution. You can easily do using merge sort, and you just use to, if you use merge sort algorithm, then the time complexity will be time complexity will be n logarithmic of n. So, and the space complexity will be of n, because you use a temporary array to store the elements, to store the sorted array, right? Okay. Okay, let us go with the okay. Now we are going to look to the better solution. Better solution. Let's go with the better solution. So okay, what I'm going to do in better solution is um, I'll take I'm going to do a single iteration to the array. What I'm going to do is I'll do a single iteration in the array, and I take three counter variables. What I'll take three counter variables. I say counter 0 and counter 1 and counter 3. Sorry, counter 2. Okay. Okay. When I was in the first element, when I was here, when I was here, when I was at 0, I'll increase the counter by 1. I'll increase the 0 counter by 1. Okay. Then I move. When I was at 1, I'll increase the counter number 1 as 1, and I move. When I go to 2, I'll increase the counter by 1. I'll increase the second counter by 1, counter 2 by 1. Then I move. And I was at 0. And I was at 0. Then I'll increase the counter 0 by 1. And it will be 2. Plus 1 is 2, right? Then I go to 1. Then I move. First element, there is 1. So I'll increase the counter 1 by 1. That'll be 2. And I move. Then the then the element is 2, so I'll increase the counter 2 by 1. Then it'll be 2. Then I move, and again there is a 1, so I'll increase the counter number 1. So then the counter number 1 will be 3. Then I move, and I got 2, element 2, so I'll increase the counter 2 by 1. Then it'll be 3. Then I move. I have a 0. Then I'll increase the 0 counter by 1. Then the counter will be 3. Then I move. Then I have 0 again. So I'll increase the counter 0 by 1. Then it'll be like 4. Then I move. And I have 0 again. Then I'll increase the counter 0 by 1. Then I'll increase the counter 0 by 1. Then the counter 0 will be 5. And I move. Then there is 1. So I'll increase the counter number 1 by 1. Then the counter 1 will be 4. So okay, when I completed the single iteration to the array, then it will be like I've got this counter 0 as 5, counter 1 as 4, and counter 2 as 3. So so I can say there are 5 zeros, 4 ones, and 3 twos. This is how we're going to do the better solution. So what I'm going to do is, what I have did here is I'll do a single iteration to the array. I've done a single iteration to the array. Whenever the 0 comes, I'll increase the 0 counter by 1. Whenever the 1 come, whenever the 1 come, then I'll increase the counter number 1. Then I'll increase the counter number 1 to 1. Whenever the 2 come, whenever the second element come, then I increase the counter number 2 to 1. So in this way I have done a single iteration to the array, and I got all of these counter 0, counter 1, counter 2. I've got how many zeros are there, how many fours, how many ones are there in the array, and how many twos are there in the array using 3 counters, right? Okay. So what I'm going to do is how I now I should need to sort this array, right? I should need to put all of these zeros here and ones here and all of the twos here, right? So for that, what I'm going to do is I'll start. Okay, let's try to code this thing. First, we just do the single. We just do. So this is. So let's try to do a single iteration to the array. So let us try to write the code and understand how it's going to work. What I say is, I'll take counter 0 as 0, initial it by 0, and counter 1 as 1. Sorry, my bad. It's okay. I say counter 1 as 0 and counter 2 as 0. Then I say, then I'll take a loop. I is equal to 0, I is less than n, I to n. Then I'll increment. What I'm going to do here is, so what I'll do here is, what I'll do here is, I'll write a condition. I say if array of I is equal to 0, then increase the counter 0, then the counter 0 will increase. And else if I say array of I is equal to 1, then I'll increase the counter 1, then I'll increase the counter 1, and else I'll increase the counter 2. So what I've done here is, so this loop is going to, this is used. So this loop is used to count zeros, ones, and twos in the array. So this is going to count how many zeros. This condition is going to count zeros. So this is going to count ones, and this is going to count zeros, twos, right? Okay. So this, we have got this. So okay, now we have what we need to do here is, we need to fill up this first place with zeros, and the second, we need to fill this first place with zeros, and second place with ones, and third place with zeros, twos, right? We should need to do in this way. For that, I'm going to write a loop. I say for loop I equals to 0. I start from the first index, and I will go to up to the counter 0, because counter 0. So here I'll go to counter 0 because up to here, up to counter 0, all elements need to fill with zeros, right? All elements need to fill with zeros. That's why I take the index up to counter 0, right? Up to, that means here counter is 5, so I'll go to 0 to 4 index, right? I'll fill up zeros from 0 to 4 index. Okay. And I say fill array of i's equal to zeros, and I write another loop. Then I'm going to start from counter 0. So this at first I have started from the 0th index, and later that I'll start it from counter 0 index, right? And it will go up to, like, I counters counter 0 plus counter 1. So you need to fill all of the ones from counter 0 and up to counter 1, right? So it need to fill all of the ones. It should need to start from the counter 0 and it should need to up to go to counter 0, counter 1, right? That's why I say start from counter 0 and counter go up to counter 1. Go up to counter 1. That's why I say this. So I say array of I fill all with all the ones and write another loop. Then this indexing start from counter 0, counter 1, because these spaces have been filled, right? Counter 0 and counter 1 has been filled. So I'll going to start from this indexing. I'll start from this counter 0 plus counter 1 indexing because these two have been filled with zeros and ones. Okay. I say and go to up to n and I say fill twos, right? So okay, we have write this. So and first all five places going to take all zeros, send it like 0 0 0 0 0 because this is it's okay. From the 0 indexing to up to here, this is count 0, right? So up to here in this indexing, the all zeros will be filled up, and I start from counter 0 indexing and I go to up to 4 places, 1 2 3 4, and I fill all of the ones. 1 1 1. Sorry, let me write this here. Okay, I'll say 1 1 1 1. I filled here up to here, right? And I go up to counter 0 plus 1, counter 0 plus 1, and I start filling up twos from the next from the filled up. This is counter 0 and this is counter 1, right? This is counter 1, this is counter 2. So I'll take this indexing to fill up all the twos. Then I say the indexing will be I equals to counter 1 plus counter 0 plus counter 1. Start from here. Start from this indexing and filled up 2 up to the n, and you can go up to n. So this is how all the zeros and ones are sorted using a better solution. Right? Okay, let us try to analyze the time complexity. Here, this loop is used to fill all the counts, zeros, ones, and twos. This is used to fill all the counters, right, from zeros, ones, and twos. So the time complexity will be go of n. We're doing a single iteration to the loop, and you can say these three loops will take the time complexity of big O of n, because here what I'm doing is I'll say counter 0 plus counter 1 plus counter 2 is equal to n, right? This is equal to n for that. And it'll be like counter 0 plus counter 1 plus counter 2 is equal to n. So the time complexity is here to fill up all zeros, ones, twos from the first index. That's going to be big of n, and this loop is first for the iteration of to do a single iteration to the array, that will be the big of n. Then the time complexity is big of n plus big of n is equals to big of 2n, right? This is with the time complexity. And space complexity will be big of 1 because we are not using any kind of extra space, or we are not using any kind of temporary array, right? We're not using so the time complexity will be big of 1. The time complexity will be big of 2, and the space complexity will be big of 1. So this is the better solution to sort an array of all zeros and ones and twos, right? Okay. So okay, today we are going to learn the optimal solution. So how I'm going to do the optimal solution? I'm going to use an algorithm called Dutch National Flag algorithm. So we're going to find out optimal solution using Dutch national flag algorithm. So in Dutch national flag algorithm, what I'm going to do is I'm going to take three pointers. One will be low, other will be mid, second will be mid, and third will be high. So I say one thing: the Dutch national flag algorithm works in through three rules. It states three rules. So first rule will be everything from the zeroth index. Okay, I'll use another pen. Okay, and so draw. I say everything will be from zero index to low index, low minus one index will be zeros. So it states first rule is everything between zero index to low index. It states everything between the low index to everything between the zero index to low minus one index will be zeros. Will be zeros. Everything in between them will contains all zeros. Okay. And second rule was low every and low minus one to I'm sorry low. I say from low to mid minus one everything will be ones. From the low index to mid minus one index, everything will it'll be ones. Everything will be ones. It contains everything will be ones. Okay. The third rule is everything between the high plus one index and up to n minus one, it'll have twos. Will be twos. Okay. Here the zero, everything will be zero to low minus one will be zeros. Right. This is extreme left. This is extreme left, and this is extreme right. This is extreme right. So okay, uh I'll explain the intuition behind the algorithm. First, I'll say intuition. I'll explain the intuition behind the algorithm. Then I'll explain the thought process, and I'll just later dry run on this. Okay. First, I'll say intuition behind the algorithm. First thing I'm gonna say is everything between. He says the the Dutch national flag algorithm states that the DNF algorithm states that everything between between zero to mid minus one will contain zeros. There will be zero, there will be zero, there will be zero, and there will be zero. Everything between zero to mid minus one will be zeros. And he says that the right next index will be low. Sorry, I have written wrong here. That is everything between zero to low minus one will contain zeros, and it's extremely at left. Extremely, this is left, right? This is extremely left. And I say everything between low to mid minus one will contains all ones. Will contain all ones. And I say the right next index of mid minus one will be mid and till high. And it contains what it contains. It contains zeros, ones, and twos. This is unsorted. This is unsorted. This will be unsorted. Okay. So we are going to use this for if the array is unsorted, right? So we have given an array that is unsorted and we need to sort that. For that, we have say mid to high will be unsorted. And the right next index of the high will be high plus 1. Will be high plus 1. And it will go up to n minus 1. And it will be go up to n minus 1. And everything here will be filled with 2's. Right, okay. So we have understand the intuition behind the algorithm. So let us see. Let us try to analyze what will happen. So what I'm going to do is I'll explain my thought process here now. I'll explain my thought process. Right. So okay, let's try to understand my thought process. What I'm going to do here is, what I'll say here is, this is my array, and I say mid is pointing here, and my high is pointing here. And my low is also pointing here. So okay, why I say like this? Mid to here, everything between mid till high, everything will be unsorted, right? This since the array is not unsorted, so everything between the mid and high is unsorted. For that, I put mid and high, and why have put the low? Why have put the low? So everything between the zeroth index and up to low minus one will be zeros. For that, I say I point here 0. I just point this low pointer here at the mid. Okay. Hope you understand this. Okay. Uh, then what I'm gonna do? In my first case, I'll explain my first case. Um, I'll use this one. Okay, this is better. So I'm going to write. I'm going to take mid as. I'm going to use this mid as mid for this algo. I'll say array of mid. I'll analyze what if my array of mid will be 0, and I analyze what if my array of mid will become 1, and I analyze what if my array of mid will become 2. What will happen? Let's try to analyze. What if my array of mid will become 0? So here is my mid, and I say here it is 0. And what I need to do, what I'm going to do is, if it is 0, and I going to swap this low with this low, then low will become 0 and my mid will become 1. And as we all know that and as we all know that uh, from the zeroth index to low minus 1 index should contain zeros, but here the low containing 1. So for that, what I'm going to do is I'll just move this low. Now the low is pointing here. Now the low is pointing here, right? And mid should be unsorted, but here one is one what one. We all know that from the low index to mid minus 1 index, all it contains ones, but the mid is pointing here 1. Oh no, this is my second case. Then what I'm gonna do is so let's try to write the first case first. What we have done when, okay, I'll explain this also, this first. Okay, I've moved this. I say mid, and everything from mid to high is unsorted. Okay, and the 0 is pointing now here, low minus 1, and the mid, and the first, this is 1 is pointing here, that is mid minus 1. Okay, what do you have did here? When array of mid is become 0, then what we have did? We have swapped this to this, right? We have swapped the mid and low, right? Okay, so okay, what I have did here is I have swapped low, and I have swapped mid. And what I have done, I've incremented the low and the mid as well. So okay, what if the, let's try to analyze the second case, that is array of mid will become 1. What if it will become 1? Let's quickly analyze this. So okay, what we have did here, here my mid, when my mid is when my mid is become 1, what I have did, I've moved my mid. So this is what we do here. When my mid is 1, I'll say I move my mid. What I've done, I'll increment my mid. That's it. So what if my mid will become 2? This is the third case. What if my mid will become 2? So this is my mid. I say my mid is 2 now. My mid is 2. And what I'll say here is, and my high is 0. What I'm gonna do? I'll swap. Then my mid will become 0. Then my high will become 2. Once my high will become 2 because 2 high minus high plus 1 2 and minus 1 will be sorted, right? But my high, what I'm going to do with the high, I'll move the high to the left. What I'll do here is I'll move the high to the left. I'll move the high to the left. Then high will be here, right? And the high will be here. And this part is unsorted. And this is sorted. It's okay. What you have done here? What you have done? I say swap when my mid value become 2. I say array of. I say my mid is swapped with high. And at the same time, it's okay, my bad. And at the same time, I've moved and moved to my left. Move my high to the left. How can I write this? I say high is moved to the left. That's it. Simple. So this is the thought process behind this algorithm. So with this three cases, we're going to do a dry run on this array. Okay, let's try to dry run on this array. Let me quickly copy this thing. So okay, let us quickly do a dry run on this. I'm going to do a dry run. Let's say dry run. Yes. Okay, right. I'm going to dry run using that three cases. Okay. And as we all know, low is pointing here. This is my mid, and this is high, and everything between high and mid, everything between mid and high will be unsorted. So okay, okay, let's look here. Look here. I think this is visible. Here my mid is become 0. What we need to do? Here we have whenever my mid will become 0, then I swap my low and mid, and I move my mid and move my low and mid. Here, if I do swap, so my mid is 0 and my low is 0. If I do swap, it'll be 0, right? Okay, because these two are pointing at the same index. Okay, then it is be surely 0, right? Then what I'm gonna do is I'll move. Once I've swapped, then I'll move. And the low pointer is pointing here and mid is pointing here. Okay, I'll quickly erase this for better understanding. Okay, this is done. The 0 is sorted. Okay. Now my mid value become 1. What I'm gonna do? We'll see here. If my mid value become 1, then increment mid. They'll say if my mid value is 1, then I'll move my mid. Then I move my mid. I'll erase this. And if my mid value is become 2, what I'm gonna do? If my mid value is become 2, then I'll swap. Then I swap my mid and high. I swap, then it will become 1. My mid value become 1. If I swap, then my mid value, then high will become 2. Okay, mid has become 1, this has become high has become 2. And after that, I should need to move to left. And I've moved my high to left. So this is how we are going to sort this using DNF algorithm. So let us see here. I know you have understand this 3 rules. So okay, let us try to do this. Have my mid here. When my mid become 1, what I do? I'll increment. I'll move the mid. I have moved the mid. Okay, I move the mid. Okay, if my mid becomes 0, what I'm gonna do? I'm going to swap the low and mid. What I'm gonna do? I'll swap the low and mid. Then my low will become 0 and my mid will become 1 here because I've done the swapping. And once I've swapped, what I'm gonna do? I'll just move both low and mid. I'll move the low here and I move the mid here. Okay, done. And now my mid has become 1. What I'm gonna do? What I'm gonna do? If my mid will become 1, then I move the mid pointer. Now my mid has become 2. What I'm gonna do? I'm gonna swap my mid and high. Then it'll become 0. And here high will become 2. Right? I'll become 2. Then I say move the high to the left. Move the high to the left. Okay, done. Right? And now my mid is 0. Now my mid is 0, and you all know very well what I'm gonna what we should need to do. If the mid which becomes 0, we should need to swap the low and high. Then we should need to swap the low and mid. Then I say swap this. Once if I swap this, then it will become 0, and this will become 1. And after swapping, we should need to move the both pointers. Then the low will be here, and the mid will be here. Right. Okay. Let me erase this for better understanding. Okay, done. Okay. So okay, and now now my mid is pointing. Now my mid is oh no. Oh damn it. Okay. Okay. Now my mid is 1. What I need to do? So now my mid is 1. What I need to do? I just need to move forward. Just need to move this mid. Then my mid is pointing here. Okay, done. My mid is now my mid has become 2. What I need to do? I need to swap the both mid and high. Yeah, then it'll be 0. Then the mid will become 2. Okay, done. Okay, done. Oh no, my mid has become 0 now. My mid has become and I should need to move the high here. Oh no, my mid has become 0. What I need to do? I need to swap my low and mid. Then it'll be 0. Then my mid will become 1. And I move the both mid and low. And I move both mid and low. Hilarious is better understanding. Okay. Now my mid is 0. What I need to do? I need to swap the both low and the mid. I'll swap it. I'll swap it. Then it'll be 0. Then my mid will become 1. Right? Okay, done. And I should need to increment this. And my mid is here at 2. And I should need to increment this low as well. Then my low is here. Boom, that is sorted. Yeah. And first, we've got all of the zeros, and we've got all of these ones, and at last we have got all of these twos. So we have sorted an array with all zeros, ones, and twos. So this is the optimal solution for sorting on sort arrays of zeros and ones and twos. So let us try to quickly analyze time complexity. Let's try to analyze the time complexity, how it's going to work. So let's try to understand what we have did here. In first case and second case, in 1 and 2 cases, what do? We increment the mid. We increment the mid. We increment the mid. We increment the mid. Once we increment the first, in first case we have increment the mid. Then it will be. Then the 0 is sorted. Then the first element sorted. Once we do in the second case, once we increment in the second case, then this element is sorted, right? I say. Then the first element is sorted. Here the second element is sorted, and I say here, and I say here is the high, and the high in the third case, high should need to decrement. High should need to decrement. When the high is decremented, then this third element is sorted. Okay, then this will be, this path will be n, right? This is up to here to here. The size is n, right? Okay. then what will be my time complexity? I say time complexity is big of n, absolutely. And what will be my space complexity? The space complexity is big of 1. So because we are not using any kind of extra spaces or arrays, anything else we're not using. So the time complexity is big of n, this is space complexity is big of 1, and this is the optimal solution, optimal approach to sort an array using Dutch national flag algorithm. So similarly, we do this for even sorting colors. This is similar. Okay.